Hi, welcome to an Arduino tutorial from Robojax. My name is Ahmed Shamshiri. I'm presenting this tutorial from Canada. In this tutorial, we are going to learn how we can use this Melexis MXL90614 infrared touchless temperature sensor to measure the ambient and object temperature and display it on a screen or use it for other purpose as degrees Celsius, Fahrenheit, and Kelvin. Perhaps you will keep the sensor on the other side for single zone, dual zone. Ours is a single zone. Explain the wiring. If you downloaded the library, and now here the sensor is located at now hitting this area. This is a. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. This is an infrared thermometer which can measure the temperature without touching the surface. This is the module. I've soldered this. Usually they ship it like this with a pin header separately, so you have to solder it. Keep the sensor on the other side and solder it here, so this way you can point it to any way you want. On this side we have a simple regulator that regulates from 5 volts to 3 volts that this module is operating. And there are 2 resistors that are needed for I2C communication, because this is also sold without the PCB. And you just need 2 resistors to use it, but this PCB just makes it easy and clean. On the module we have VCC, which will be connected to 3.3 volts or 5 volts, and then we have ground. This will be connected to ground. SCL and SDA are 2 pins for I2C communication, which I'm going to show you. Measure the temperature using infrared. Needs to have a line of sight access to the surface. There are different versions of this available, and this version is having a 90 degrees. There are different models of this available with different angle and quality. This is the cheapest one perhaps, with 90 degrees angle, meaning this will measure 90 degrees. So if I measure the temperature, it's actually measuring all this area. And the further the object, inaccurate the value, because it will measure long ways. In terms of 90 degrees, you see this, it will be very long. So keep that in mind. But there are different models of this available in terms of accuracy and angle of view. This module is offered in 2 variations. One is from -40 to 125 degrees Celsius, and the other is from -70 up to 380 degrees Celsius. The accuracy of this one is 0.5 degrees Celsius, but there are a lot of other factors will affect the measurement. And here it has been displayed on Adafruit website. You can use it directly from this point. You see this piece. You can see this is ground and this is the power. You can connect it directly to 3.3 volts, and between this point you just put a resistor to 5 volts and it will work. The module is sold on AliExpress. If you search for MLX90614, you will see that it is sold for $36 plus shipping, Canadian $25. On eBay, you can get it for $7 plus shipping, or $9 depending on the type that you select. And the module that I'm using with a close-up magnifying camera, BAA, that's the model BAA180, and then I turned it around, A18. So we got BAA18. If you pay attention here, ours is 3 volts, but we have a regulator to regulate 5 volts to 3 volts, so we are not worried. B and then AA. A is single zone, the second one, and then the second A is standard package. The I2C address that it uses is 5A. This is a hex value. Supply current is 1.3 milliampere. Sleep mode current is 2.5 microampere typical. At ambient temperature of 85 degrees, it can keep the data for 10 years, the data retention time, and also reading and writing for ambient temperature of 25 degrees will be 100,000 times, but if the temperature increases to 125 degrees Celsius, then it will be 10,000 times. Erase and write time is 5 milliseconds. Here the voltage is mentioned that if we have A, it will be 5 volts, and if we have B, which is the module that I'm using, is 3 volts. And if you're using external component with A, it can work from 8 to 16 volts, and there is a typical application suggestion in the data sheet. And here are the addresses in the ROM. The temperature maximum is stored at this address, minimum is stored at this address, and then the control and temperature range and all other values, these are the addresses that are being read by the code. This is for AA version, and this is the angle. As you can see, from minus 90 to 90 degrees from this center point, it measures from minus 50 to 50 degrees in both sides. So that's very important to know. This is for dual zone. Ours is single, so we don't have two pieces. We are measuring only single zone. This is for CC. As you see, there are versions that the accuracy is increased, and then even we have, you see, around maybe 5 or 3 degrees. So this becomes more accurate. There are different versions, CH and CF. For further information, I will provide you this data sheet so you can have a look at it. If you want to learn Arduino, I have a bestseller course on Udemy where you can learn Arduino from ground up with hundreds of projects, all course material, library, codes, wiring diagram, everything available in one place. The link for my Arduino course is below this video in the description. If you need the wiring diagram for this, it's available as part of my Arduino course at udemy.com. Now let me explain the wiring. From this side, the VCC is connected, the VN is connected to 5 volts of Arduino Uno. The GND or ground is connected to the ground. This is SCL pin. The SCL is connected using white wire to A5. SDA using this black wire to A4. We also have SDA and SCL in here. You can connect to these two last pins. I've used this Adafruit MLX 90614 library. I will provide you the link, and also I will provide you the zip file in case they change it and the code will not work. But if you want to download it from here, just click here and download zip. Or from the link that I provide you, download the zip file in your computer and save it. Once you downloaded the library, click on Sketch, Include Library, and then select Add the zip library, and then point it to where you have saved it. In my case, inside Download, Tutorial, and here is the library. Click Open, and it will be installed. After that, close Arduino and reopen it. Now you will be able to see the examples. If we go click on File, Examples, here Adafruit MLX 90614. So it's available. I'm just clicking and opening it. Now let me explain the code. Full explanation of the code is available as part of my Arduino course at udemy.com. Here I'm just going to show you how to print the text and how to get it. These two texts are the value that are displayed here, this ambient and object. To get the temperature, you just type print and temp, and inside a single quote put capital letter C. This will give you the temperature of the object in Celsius. And if you want to get the temperature of ambient surrounding area of that object or something else, then just put D. I use D because D was not used somewhere else, and that is the second letter after C. Then if you want to get the temperature of an object in Fahrenheit, use this capital F. And if you want the ambient, the next letter after F is G. That will give you the temperature in Fahrenheit for the ambient. If you want to get the temperature in Kelvin for an object, use this line with K, and after K there is L. L will give you the ambient temperature in Kelvin. And this line just prints these dashes, so you know that the code has ended and next reading will start. I've put this 3 seconds so we can wait a little longer to be able to read the text, but you can change it to a smaller value of around 5 milliseconds or greater. Now if you want to just get the temperature, we use this get temp and F. So here, for example, if you want to get the temperature in Celsius and you want to do something and compare it, if it is greater than 40, then do something, and here this is opening and closing, and put your code here. Let's say you want to turn on a relay, a fan or device or something, or turn off something, or turn on a camera, whatever you want to do it here. If you want to learn Arduino, I have a bestseller course on Udemy where you can learn Arduino from ground up with hundreds of projects, all course material, library, codes, wiring diagram, everything available in one place. The link for my Arduino course is below this video in the description. And here is a demonstration. I'm using Arduino Uno. It is connected. I have placed here a ruler so you know in terms of a distance what is the effect of it. This box is now at 0, and now here the sensor is located at 100 millimeter or 10 centimeters. At the moment on the serial monitor it shows whichever you're paying attention to. For example, Celsius, 24.5 degrees Celsius. Because the angle of incidence is now in a certain distance, you will read different value. Because the angle of this one is opening with 90 degrees. This angle is 90 degrees. Pay attention that when I put this here, it is reading all these area and is giving me the average. So this is the average temperature from all these areas. From this point it is 90 degrees, so it's huge. To get accurate measurement, I have to be very close. So this now it is measuring from this point up to this point. Now that is where it gives you 24 degrees. Here this is the distance we are measuring all these areas. Bring my hand, it now measures around 30 degrees Celsius, or as you can see 86 degrees Fahrenheit. The distance is affecting it, and different version of this will have different angle of view. Increase the accuracy of this, we need to put some kind of lens here to direct the infrared and also compensate if there is any deviation or variation in the reflection. Because if you put some lenses, you can direct it to narrower area. Instead of 90 degrees, you can make it narrow and narrow, and then the angle of incidence will be smaller, and as a result you will get a better reading. I've placed it at 100 millimeter or 10 centimeters. As you can see, it is reading 24 degrees Celsius. Now I'm getting a heat gun. This is a Mastercraft heat gun from Canadian Tire. I am applying heat on this surface, making sure the heat doesn't hit this object. The sensor, the ambient temperature, it shows now 28 because I was just testing it and missed the recording, so I'm doing it again. Now this is now hitting this area. And here you're reading temperature now 41 degrees Celsius. That is from this surface. And if I rotate this side, it is a little cooler and the temperature should be a little different now, 26 degrees. If I bring this back, you should be able to read a higher temperature now, 28 degrees. This is a heater turned on. I'm going to point it towards this heater and measure the temperature. This is now pointing to somewhere where I'm going to bring the heater. As you can see, it is reading 100 degrees Celsius. Thanks for watching. This was how to use this MLX 90614 infrared touchless temperature sensor. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it at the comment section below. I try to answer and reply. If you want to get updates of my upcoming videos, make sure to subscribe. Typically it needs 1.3 milliampere to operate when it's measuring, and also 1.5 milliampere when you're programming it. And this is the heater that I was bringing in front of it.